I like bigger fingers.
All right, so go ahead and open up your books to page 310. We're going to review factoring from, you learned most of the stuff that we're going to cover today you learned in Algebra 1, but it's been a while, and then there are a few factoring techniques that maybe you didn't learn in Algebra 1, and we'll cover those today as well. Okay, so starting off with the review part, when you're factoring a polynomial, the very first thing you want to do is look at all the terms in the polynomial and decide if there's a common factor. Okay, so looking at this example A, looking at all the terms, first just focusing on the variables, there's an x in every term. So we can factor an x out in front. And so if I factor an x out in front, that's just like dividing each term by x, because putting it out in front is multiplying by x. And so the first term, 6x cubed, if I divide that by x, that would just be 6x squared. And the second term, if I divide by x, would be 15x. And the third term divided by x is 6. Okay, so I factored out the x. And then looking at those terms again, now let's look at the numerical part. What number goes into 6, 15, and 6? 3 does. And so we can pull a 3 out in front as well. And now I have, if I divide each term by 3, that is 2x squared plus 5x plus 2. And then we check to see, can that, the quadratic part, the part that has a second degree, can that be factored more? And so going back to some techniques that you learned in algebra, factoring quadratics, there are a few different techniques. What I prefer and what I think is probably going to be the most efficient for you is to understand what parts of a polynomial come from the original binomial. So I'm just going to do a little side problem over here. You don't need to write this down. Just watch and listen for a moment. And so if I have something like, let's say 3x plus 2 times x plus 5. When I FOIL this out, that would be 3x squared plus 15x plus 2x plus 10. So what we want to recognize is that the first term came from the first two parts of the binomials. The 3x times the x gave me 3x squared. And now look at the end of the answer. 10 came from 2 times 5. And then the two middle terms add up, in this case, add up to 17x. Those came from the outer and inner. So in FOIL, we have FOIL, first, outer, inner, last. The outer and the inner gives us our middle term. And so understanding where all those parts come from will help us when we're trying to factor a quadratic. So now if we go back to this problem that we were trying to factor here, in order to get a 2x squared, there's only one way that we can get a 2x squared, and that is to multiply 2x times x. So the first two terms will give us the 2x squared that we need. The last term is a 2. So to get a 2, the only way to get a 2 is to do 2 times 1. Okay? But we might have to try that, or it could be 1 times 2. And those are going to be a little bit different because they don't have the same factor in the front. So we have to try both of these until we see which one works, or maybe neither one of them will work and it's not factorable. Okay? So I notice I didn't put any signs in. I didn't put any pluses or minuses in either one of these. But we're going to try them both until we find the one that works. And so I'm just going to multiply these out without signs. This would give me 2x squared. This would give me 2x. Shouldn't have a plus there, just a 2. This would give me 2x. And then this would give me 2. So we'll figure out the signs later, but is there any way I can put in pluses or minuses so that those two terms can add up to 5? I'm trying to get a 5x in the middle. 2x and 2x will not give me 5. Doesn't matter if I make one of them positive, one of them negative, that'll never give me 5. So it doesn't look like that combination is going to work. Okay? So then I try the next one. I switch the 2 and the 1. So it was 1 and 2, or I did 2 times 1, so now I'm going to try 1 times 2. And so that would be 2x squared, 4x, 1x, and 2. Is there any way I can arrange the signs so that these two add up to 5x? Yes, if I make both of them positive, then I get the correct factorization. So in order to make both of those pluses, I'd have to have pluses inside the parentheses for both of those. All the terms are positive, so it makes sense that both of those would be pluses on the inside. And so this is the full factorization. We can check all 3 of the factors again, and we see that none of those can be factored anymore. And so our final answer then is 3x times 2x plus 1 times x plus 2. So that is one of the methods that you can use to factor. Another method that you might have learned in algebra is to factor using the x method, where you put up in the top you put AC, and down in the bottom you put B. And so in this case, A is 6, B is 15, C is, oh actually I should do that from the factored version. So from here, there's A is 2, B is 5, C is 2. So AC would be 4, and B is 5. So we're looking for 2 numbers that we can multiply to get 4 that add up to 5. So 1 times 4 multiplies to get 4 and adds up to 5. And then we have to go to the box from there. And so we know we're going to have a 2x times an x to get 2x squared. And then this is telling us that we need a 1 and a 4. So this first box is going to have to be 2x squared. And then we need a 1x and a 4x. There's no way I can get a 1 here, because nothing times that is going to give me a 1. So I'm going to put the 1 on the diagonal. These need to be 1x and 4x in order to give me the 5x that we need in the middle. And so to make that work, that would have to be a 2, so that 2x times 2 gives us 4x. And this would have to be a 1, so that x times 1 gives me x. And then our ending term is 2. And so now we look up at the top to get our answer. That is x plus 2 on the side times 2x plus 1 up on top. And that's the same factorization we got by doing the trial and error method. So whichever method you're comfortable with, that's fine. I prefer the FOIL and trial and error method, so I will do all the problems that we do that way. But if there's ever a problem that we do and you want to see it by the X method or the box method, then just let me know and I'd be happy to do it that way for you. Okay? Some people are more comfortable using this technique, but you do have to do both. You have to do the X and the box in order to get the answers that way. Okay? All right, so let's take a look at example B on the next page on 310. So in this one, what is something that I can factor out of both terms? 2x. So in the previous problem, we did it in 2 steps, but you can always do it all in 1 step like that if you want. So if I factor out a 2x, what am I left with? X squared minus 10. Okay? X squared minus 10. And so we have 2x times x squared minus 10. And that is factored completely. X squared minus 10 cannot be factored. And so that is it. That's factored completely now. Okay. Go ahead and try problem number 4 in your groups. Raise your hand if you get stuck, but remember the first thing we always want to look for is a common factor. Once you factor out the common factor, then try to factor it using two binomials. Okay, so first we're going to factor out a 3x, or sorry, we're just going to factor out an x. If we factor out an x, then we're left with 3x squared plus 7x plus 4. Okay, and there are several factor pairs that we could try for this. For example, just to see how to factor the quadratic part, look at the ones that we need to consider. We have, to get a 3x squared, it's got to be a 3x times an x. To get a 4, there are several different ways to do that. We could have 2 times 2 to get 4, or we could have 1 times 4 would also give us 4, and 4 times 1 would also give us 4. So there are 3 different possibilities, and we need to try all of them until we find the one that works. Okay? So for example, this first one, if I distribute, that's going to give me 3x squared, 6x, 2x, and 4. Now looking at the middle terms, it doesn't matter if I make one positive, one negative, or both positive or both negative. There's no way I'm going to get the 7 in the middle that I'm looking for. And so that possibility does not work. There's no way I can get a 7x for my middle term using that combination. Okay? Which one does work?
The last one.
The last one. The last one works if I do 3x plus 4 and x plus 1, because if I distribute that, notice that I get 3x squared, 3x, and 4x plus 4. The middle term does add up to 7 like I want, 7x, and so that is the correct factorization, and so there our answer is factored completely. If you look at all 3 factors, none of them can be factored anymore. Any questions on that one? Okay, now the next part, they give you all these special factoring forms. Now the first one you should be pretty familiar with from Algebra 1. Difference of squares. So difference of squares should be really easy to factor if you recognize when you have difference of squares. For example, if you had something like x squared minus 25, that's a difference of squares because x is squared and 5 is squared. So it's x squared minus 5 squared. And so we can always factor a difference of squares by using conjugates. So this would be x plus 5 and x minus 5. So you should look forward to seeing difference of squares because they're so easy to factor. Another example would be if I had, let's say I had x squared minus 100. That would just be x times x to get x squared, 10 times 10 to get 100. Make one of them plus and one of them minus. Those are called conjugates. So you can always use conjugates to factor difference of squares. A harder one would look like this. If I had something like 25x to the 4th minus 36. That is also a difference of squares. What am I squaring in the first term? What do I have to square to get 25x to the 4th? 5x squared. So it would be 5x squared times 5x squared would give me 25x to the 4th. And then 36 is 6 times 6. Make one of them positive and one of them negative. Okay? So those are all difference of squares. Those, I know for sure you saw those in Algebra 1. Okay? And those should be easy. You want to look forward to a difference of squares. Okay? Those are easy to factor. All right? The perfect square trinomials, under that, you may or may not have done that in Algebra 1. It's not really that big of a deal because even if you don't recognize that you have a that you have a perfect square trinomial pattern, if you just factor it like the previous examples that we did, you'll get the correct answer in the end. Then something new that I don't think you saw this in Algebra 1 is the sum of cubes and difference of cubes formulas. So those we can use anytime we have something cubed plus something cubed, or something cubed minus something cubed. Okay? So take a minute in your groups and compare those two equations and see if you recognize any patterns that might help you remember one from the other. Go ahead and have a 1-minute discussion in your groups. All right, Amy, what did you guys notice about the formulas?
We got that pretty much the signs are different and everything else is the same. So for the sum of two cubes, it's plus plus minus plus, and the difference is minus minus plus plus.
Okay, I see what you're saying. So you're saying plus, so plus plus minus plus, okay, and then minus minus plus plus. So that's one way that you could remember it. Or you could notice that the first part of the factorization has the same sign, and the second one has the opposite sign. So we have same and opposite. Same, opposite. Okay? And then the last sign for both of them is always plus. Okay? So whatever patterns that you recognize there, hopefully that'll help you distinguish the difference between the two sum of cubes and difference of cubes formulas. Okay? If we look at example A, they've got that worked out for us. But here's how my approach might be just a little bit different. First, I would suggest that we identify what is A. So what is being cubed for that first term? What do we have to cube to get 27x cubed? 3x. So A would be 3x, and then what are we cubing to get 64? 4. 4 times 4 times 4 is 64. So now that I've identified what A and B are, I can just go straight to this equation and say that this is going to be A plus B, so that would be 3x plus 4. And then it says, now we're going to have A squared. So what is 3x squared? Right? What do you get when in place of A squared? What should I write?
3x squared.
And what is that? What's 3x quantity? What is this? 3x quantity squared. What's 3x times 3x? 9x squared. Okay? And then when it says A times B, Tulu, what should I write?
It should be 3 times 4, so
12x. And then it says B squared. Joseph, what should I write? 16. So that's using a sum of cubes formula to factor that sum of cubes. Okay? All right, try example B. You can either fill in the blanks or just do it on your own, but I would suggest before you do anything, decide as a group what is A and what is B, and then use the appropriate equation to factor it. Okay, Matthew, what quantity should we cube to get 8x cubed?
For A and B. Sorry,
Yeah, so what's A? So what?
A is 2x and B is -3.
Just 3, because we're already recognizing it as a difference, so we don't need to put the negative in for that. So we would cube 2x to get 8x cubed, and we would cube 3 to get 27. So now we've identified A and B, and so plugging into this part of the equation, that's going to be 2x minus 3. In place of A squared, if I square 2x, that would be 4x squared. A times B is 6x, and B squared is 9. So if I write that we would have that factorization. Now you could always try to factor the remaining quadratic as well. Sometimes the remaining quadratic can be factored. So if I wanted to check this, see, can that be factored? Since it has fairly large numbers, I might want to just go straight to the quadratic formula. So if I plug that into the quadratic formula, that would be x equals -6 plus and minus the square root of b squared, which is 36, minus 4 times a times c over 2a, which would be 8. Okay? Now notice that underneath the radical, I'm going to have a negative. That's 4 times 4 is 16 times 9. What's 16 times 9? Is that 144? So we have 36 minus 144, which is negative 108. So since I have a negative under the radical, that means that's not going to be factorable. In order for it to be factorable, this square root part would have to turn out to be a whole number. Like if it turned out to be the square root of 9, then I would just get 3. So if I get a rational number when I do the quadratic formula, that means the quadratic is factorable. Since this one turned out to be irrational, that means it's not factorable, so I know I'm done. Okay? And then the next question is related to what we just did. We have, if we now take that same polynomial and set it equal to 0 to find its roots, it's a third degree polynomial, so it should have 3 roots altogether. We get the 3 roots by setting the factors equal to 0. Okay, we want to know, when is this whole thing equal to 0? When that's 0, or when that's 0. So what x value will make 2x minus 3 equal to 0? What do you think, Owen? What x value will make 2x minus 3 equal to 0? It sometimes helps if you write it out like this. 2x minus 3 equals 0. Add 3 to both sides. What are you going to get?
3 halves.
Good, 3 halves. So after you do a few of those, then you'll get good at recognizing that in the fraction, or in the factor rather, it's just going to be that number divided by that number. It's the 3 divided by the 2, and opposite in sign. Okay? So there's one real solution. Okay? So we have one real root, and then we still want to figure out if there are any more real roots, and setting this equal to 0, 4x squared plus 6x plus 9 equals 0. Well, I just did that right up here, didn't I? It has solutions x equals -6 plus and minus. If I simplify the square root of 108, 108 is 36 times 3, so that would be 6i root 3 over 8, which is -3 plus and minus 3i root 3 over 4. Okay, so since that has imaginary solutions, or an imaginary number in it, we'll say we have 2 non-real roots. Okay, so it was a third degree polynomial, so we knew there were going to be 3 roots altogether. One of them is real, 2 of them are non-real. Any questions on that one? Okay. Try number 6 in your groups. Raise your hand if you want me to come and help your group out. Okay, Haven, what can we factor out first?
First you can factor out 5x.
Okay, good. So if you factor out 5x, we're left with 8x cubed plus 1. And that is a sum of cubes, because if you cube 2x, you get 8x cubed. If you cube 1, you get 1. So this is a sum of cubes. And so factoring this using the sum of cubes equation would be a squared, so that's 4x squared, plus ab plus b squared. And then if we wanted to see if that could be factored more, we can just check real quick in the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. And I can see right away that I'm going to end up with a negative under the radical again, so that means it's not going to be factorable. And so I'm done. I actually have one mistake. Oh wait, actually, I didn't put in the first part of the factor. I missed the first term. So let me just start that over again. So this is going to be a plus b, and then a squared plus ab, actually minus ab because it's opposite, and then plus 1. Sorry about that. Okay, so that is, do you agree with that? Is that the correct factorization?
Yeah.
So then trying the quadratic formula, it's all going to be the same, except that's going to be plus 2, and everything else will be the same. But we still get a negative under the radical, so that means the quadratic part is not factorable. So that would be it. Yes?
If it's a positive number under the square root, would you still have to simplify it, or is it only when it's a perfect square?
Only when it's a perfect square. So if we ended up with, let's say, the square root of 7 under here, that's still irrational, which means it's not going to be factorable. Okay? So it has to be a rational number. That means something that, so if we get the square root of 9, then we're going to get a number 3 out of that. And so that means it is going to be factorable. Okay? All right. So on page 313, this is another factoring method that you may have been exposed to it in Algebra 1, depending on how much time you had near the end of the year in Algebra 1. So some of you have done it, some of you haven't. I'm going to go through it as though you haven't seen it before. And I think the examples they gave here are really kind of similar to each other, and so I think it'll be better if I do a separate example first. So go ahead and copy this problem down in the margin. We're going to factor this one by grouping. So just write this down and we'll do it together. So the way that grouping works is you have to have an even number of terms in order for grouping to work. And by the way, grouping doesn't always work. Even if you have an even number of terms, grouping doesn't always work, but it's something that you can always try and see if it'll help you factor. So when you have 4, in this case we have 4 terms, so we can try grouping. So we just group the first 2 terms, and then group the second 2 terms, or the last 2 terms. Okay, so we have the first 2 and the last 2. And we're going to try to factor those individually. So Fahim, what can I factor out of the first group?
X squared.
Good. So if we factor out an x squared, what are we left with? Good. So we're left with 3x plus 2. Okay? Now look at the second group. The 9x plus 6. Michael, what can I factor out of 9x plus 6? Okay, 3 goes into both of those, so that leaves me with 3x plus 2. Okay? Now I can tell that grouping is going to work because we got the same factor. Okay, we got 3x plus 2 from both of them. If we get the same factor, grouping is going to work. If we don't get the same factor, that means grouping isn't going to work, and so we abandon that and try something else. Okay? But in this case, they do turn out the same. And so now what I'm going to do is take the 3x plus 2 and pull that out in front. Okay? And so if I pull the 3x plus 2 out in front, what's left? The 3x plus 2's are gone. I pulled those out in front. What are we left with?
3x squared.
We're left with an x squared plus 3. And so that is the factorization for that problem. We can check both factors. Neither one of those can be factored anymore. 3x plus 2 cannot be factored anymore, and x squared plus 3 cannot be factored anymore. So now I'm done.
Why isn't it 3x plus 2 squared if you combine the two of them?
We didn't combine them, we just pulled them out as a common factor. So now notice that if I do the distributive property, if I multiply 3x plus 2 times x squared, that would give me that. 3x plus 2 times 3 would be the same as that. So it's no different than if you had something like this. Let's say I had 5x squared plus 3x. If I write the 5x squared as 5x times x and 3x times x, when we factor that, what we're doing is we're pulling that x out in front, so it becomes x times 5x plus 3. And so we didn't make that an x squared, right? We just factored out a common factor of x. Okay, so the same thing as what we're doing here. Now we can take a look at their example A. If we take their example A and group it, x cubed minus 2x, x cubed minus 2x, and then x minus 1. Okay, if I factor the first group, I can factor out an x. Sorry, that should be, I didn't write that in the problem correctly. That should be x squared. So I can actually factor out an x squared, and that leaves me with x minus 1. Now in the second group, the reason why I didn't want to show this problem first is because this is already factored. X minus 1 is already factored, so all we could pull out is a 1. And since I have the same factor, x minus 1, I can pull that out in front, and that becomes x minus 1 times what's left is x squared plus 1. And then that's factored completely. Yes?
I think our books are different. We have,
You don't have the same problem?
plus x squared. Mine's the same.
No, mine's minus.
Mine's the same.
Mine says plus.
So you mean this sign right here is different in your book?
Yeah.
Okay.
For some people.
So I think if you change those signs, it may not. Well, let's see. Someone that has the pluses, what is the equation? X
Cubed plus x squared plus x plus 1.
Okay. So what you're talking about is the second one then, right? Oh no, that's actually different. So you have, some of you have x cubed plus x squared plus x plus 1. So this is factored, you can factor this by grouping as well. So this would be x squared times x plus 1 and 1 times x plus 1. So if you have that book, then you would factor out the x plus 1 and you'd be left with x squared plus 1. So it's a very similar problem. I don't know why there are two different versions of the book, but both of them work by grouping. Okay? Let's go to problem 7. The one that's printed in your book, go ahead and try that one as example A, and then add on example B, and try that one as well. Okay, so example A, after we group, if we factor out an x squared, we're left with x plus 3. And then the second factor, we can only pull out a 1. That's 3x plus 2. Now, since these factors are not the same, this grouping method is not going to work. So it might be factorable, but it's not factorable by grouping. Okay, so that's not factorable by grouping. If you really had to factor it, you could try graphing it on your calculator and see what the zeros are, and that might help you factor it. But for this example, we're just trying to factor it by grouping, and grouping doesn't work. Okay, so then if we go to example B, we have x. Let's see if we I'll just rewrite the grouping down here. So this would be x cubed minus x squared as one group. Now you have to be careful with this negative sign. If you leave the negative out here, then it changes to 4x minus 4, because negative times negative is going to give you the positive 4 that you had. So you could do it that way, or what I suggested earlier is to change it to a plus and bring the negative with the 4 and make it negative 4x plus 4. So now what you need to do when you factor the first one by grouping, that is going to be x squared times x minus 1. And then we would factor out a negative 4, which makes it negative 4 times x minus 1. And so we do get the same factor here. Bring that x minus 1 out in front. And what are we left with? X squared minus 4. Okay? Now to see if we're done, x minus 1 is factored completely. What about x squared minus 4? Can that be factored anymore? X squared minus 4?
X minus 2 squared. X plus
Not quite. It's a difference of squares, right? So difference of squares can be factored using conjugates. So what would that be, Timothy? X plus 2, x minus 2. Anytime you have a difference of squares, you can factor it using the conjugates. That means 1 plus and 1 minus. X plus 2 times x minus 2 gives you x squared minus 4. And so that is the complete factorization of the original problem that we had. Okay, any questions? Okay, we'll go ahead and stop there.